Hi, this video will outline the assembly of a cardboard microcontroller, which can bring your paper mech projects to life. Here are the tools you'll need: a wire stripper and cutter, a soldering iron and solder, a pushpin, and tape. To build the microcontroller, you will need black, red, and yellow 22-gauge solid core wire, an ATtiny 85 processor, an 8-pin socket, a single-pole double-throw switch, two 3x1 male pin headers, one 3x1 female socket, a female 2.1mm barrel connector, an LED, a piece of illustration board with a circuit diagram glued on or a laser-cut cardboard base. It's also helpful to have copies of the circuit diagram and wire length guide handy. You'll also want a 5-volt, 2-amp switching power supply or battery pack, a tiny AVR programmer, a photoresistor, potentiometer, or other analog input device, and up to 2 servo motors. If you are using a printed template, you must punch the marked holes with a pushpin. In my case, the barrel jack didn't fit the laser cut holes, so I made a new one. Next, we need to prep all our wires. Check to make sure that the wire length template is full scale using a ruler. I suggest cutting the wires a bit longer than shown on the template because it's easier to work with the longer wires and trim the excess later. To get the best result, bend and strip the wires to fit your board. I like to strip one end of the wire, bend the wire to fit, and then strip the other side and trim off the excess. Bend the exposed lead straight down so that the wire drops through the cardboard, and then bend the ends towards their respective pinholes. Some wires will require more insulation to be stripped off in order to bridge multiple pinholes. We want the exposed wires to reach their target pins, but not touch other wires, which could cause a short circuit. Place the 8-pin socket into the board, minding the orientation of the indentation in the base. We're now ready to begin soldering the components into our cardboard. If you have trouble managing your wires, you can secure them to the board using Scotch tape. We want the socket to be firmly held by its solder connection so that it doesn't pull through during the removal of the ATtiny chip. The connections that you need to solder are indicated with blue dotted lines. Bending the leads on the power switch and LED will help keep them from falling out during soldering. The long lead, or anode of your LED, should go through the hole marked with the plus sign. Finish soldering in all your components using the circuit diagram as a guide. Once you've checked all your connections, you can plug in a pre-programmed ATtiny, power, and servos, then test out your cardboard microcontroller. Happy tinkering!